Another important effect of surface tension is called the capillary effect. So the capillary effect is defined as the rise or fall of a liquid inside a small diameter tube which is inserted into a liquid. So for example, if we take a container filled with water and we insert a small diameter tube made of glass, for example, you will observe that the water will enter this tube until it reaches a level equal to h, and we will see that the free surface will be curved up, and we say in this case that the water wets the glass. So as you can see that the water will rise to the glass and will stick to it. However, if we replace water by mercury, for example, we will observe that the mercury inside the tube will be depressed and it will reach a level below the liquid level at the reservoir, and the free surface here will be curved down. So as you can see in the example of water, we have a capillary rise phenomena, and in the example of mercury we have a capillary fall phenomenon. So this effect can be explained microscopically. By considering cohesive and adhesive forces. So first let's define what is a cohesive force. So cohesive forces are just attraction forces between like molecules. For example, between water molecules and other water molecules, or between mercury molecules and other mercury molecules. And adhesive forces are just attraction forces between unlike molecules. For example, between molecules of water and molecules of glass, between molecules of mercury and molecules of glass. So the relative magnitudes of the cohesive and adhesive forces determine whether the liquid will wet the surface or not. So in the case of water, the adhesive forces to the glass are greater than the cohesive forces between the adjacent water molecules. So here, if we look at the liquid solid interface, at the contact region between the liquid water and the solid or the glass, so we see that the water molecules are more attracted to the glass than they are attracted to each other. So that's why the water will tend to rise to the glass and will stick to it. However, in the case of mercury, the cohesive forces between the mercury molecules are greater than the adhesive forces between the mercury and the glass. So that's why the mercury molecules are more attracted to each other than they are attracted to the glass. So that's why they will be crowded here, and they will form a free surface that is curved down. So in this case we say the mercury does not wet the surface. So the mercury does not wet the surface. If we want to calculate the capillary rise H, for example, let's take a column of liquid that has the level H and draw its free body diagram. So if we take this column of liquid which has a height equal to H and draw its free body diagram, so we'll have the weight downward, and of course we have a pressure distribution at the bottom and a pressure distribution at the top. However, at the bottom, if we take 2 points, one inside and one outside of equal pressure, we will see that the pressure distribution at the bottom is equal to the atmospheric pressure. So the two forces at the bottom and the top will cancel out. And here we have also the surface tension force tangent to the liquid surface at the contact region between the liquid and the solid, with an angle to theta equal to theta with a vertical line, and theta is called the contact angle. So it is obvious if the contact angle is less than 90 degrees, then the liquid, we say the liquid wets the surface, as in the case of water. And if theta is greater than 90 degrees, as in this case, so here if you draw the surface tension, you can see that the angle theta is greater than 90 degrees, so the liquid does not wet the surface. So let's now calculate the weight. The weight is just the mass of the liquid column into the gravity, and the mass is rho into volume into gravity. So the volume of this liquid column, so we have rho g into the volume, which is pi over 4 d square. D is the diameter of the tube, so here d is the diameter of the tube, into, so we have pi over 4 d square into h. And the surface tension force T is just sigma into the perimeter of the free surface, which can be approximated as pi into d. So by force balance, summation of forces is equal to 0, and we project in the y direction. Let's say this is the y direction, so summation of forces in the y direction is equal to 0. So we will have sigma s into pi d into cosine theta will be equal to mg, will be equal to rho g pi over 4 d square into h. So we can pi d and pi d can cancel out, and we will have that the capillary height will be equal h equal to 4 sigma s cosine theta over rho g d. So from this equation it is obvious that the height h is inversely proportional to d. So it is important when doing pressure measurements using manometers or barometers is to choose a tube diameter D that is large enough to minimize capillary effects. So in this way we can have pressure readings that are more accurate when using manometers or barometers.